I'm Rich from Inside HPC, and my guest today is Sharan. Sharan, you've been in the HPC industry a while now, and I asked you your title before we started here and the things you're affiliated with. What, who is Sharan, and what are you doing these days?
Well, these days I'm a manager of special projects over at a new university in the Middle East called King Abdullah University of Science and Technology.
Yeah.
It's very new, 2 years old, but its basis is computational science and modeling. That's one of our pillars.
Okay.
So, Rich, as I was saying, my perspective will largely be based from a person who came from the industrial, commercial manufacturing sector. And in the early days when I was running HPC over at General Motors, we used to run it just to see, where we fit on the list. Then we started realizing quite a few things, and after a couple of years, we actually avoided running the top 500 HPL, LinPack benchmark.
Even though you had
Oh yes, we had
substantial
substantial.
Sure.
I can share that in those days we had about 10,000 cores under a single roof. We're talking, mid 2000 out here,
Okay.
2002, 2003.
Okay.
And when I last left, we had over 17,000 cores. So it was substantial. But what we found out is that the benchmark itself for the top 500, it took up several days of a production machine. And we felt that it was very hard for us to explain to the management who bought this machine for improving the car designs, but not only that, accelerating the design process, because every day you saved on design time, you saved several $1 million.
Yeah.
And they couldn't understand why you needed sometimes a week just to run a benchmark when they could be, having 1,100 engineers running all sorts of simulations in all domains.
Sure.
So we felt kind of a little bit, we wanted to give the feedback here that maybe they could think about having a couple of varieties of these, and one which could act as a litmus test.
Okay.
And not take up too much time as these systems grow.
Yes.
I think everyone would agree that they can continue running it, continue collecting the data. It's worked this far, but there's always room for improvement.
Yeah.
The other thing is that it's great for people who are running the same kind of work, but our manufacturing industry workload is quite different than that of the national labs or of the universities. We were dominated by massive data sets being sucked into the machine, not just compute, but very, very large memory models and systems, and all competing for resources. So this only measures maybe perhaps 1/3 or a fraction of the total capability of the system we
You're
put
talking
together.
about the LinPack benchmark.
That's correct.
Right,
Yeah.
okay.
So something that would reflect the large memory, some kind of models of that. So maybe that's another room for improvement for the LinPack benchmark, which shows up in the top 500. Yeah.
Right. Okay.
The other thing I would talk about is why limit it to 500? When they first started with this several years ago, they picked a large number and they thought they could encompass everyone in the world.
Sure.
It's been several years, and yet systems have grown bigger. Floating point operations have grown bigger, yet we're artificially limiting it to just 500. There's several hundreds of thousands of systems out there.
Okay.
So that would be, something. And
Okay.
maybe what we can do is, just like the folks who conceived of this, they wanted to know what kind of systems would be for the kind of work they did, and that's fine.
Yeah.
But maybe what we can do is complement that by looking at other industries and seeing what they do and picking something representative for that, and they can continue doing this, but I think they should spin off, sort of top 500 for specific industries.
Sure.
And formulate a workload that would push the boundaries and let them know what those systems are capable of.
Okay, so that makes sense. I mean, there's the Fortune 500, there's the Fortune, what is it,
1,000, yes,
yeah.
yes.
So, but this 500 number, I got to tell you, has been picked up by all kinds of others, right? It's gonna, I think it's gonna get the Green 500, the Graph 500, yeah. So, and they can't even fill it. those, they can't even get in.
Well,
right?
that's quite all right. When
Yeah.
the top 500 was initially
Right.
there, they probably had trouble filling it then.
Yeah, yeah.
And now there's a lot more.
Sure.
You got
Okay.
all the Chinese system, Japanese, Asia's
Yeah.
coming up. So I think 500 is probably a small number. They can still extend it to top 1,000.
Yeah.
And for historical reasons,
Okay.
they can always pick
Okay.
500 for comparison.
Yeah. Well, I was talking to somebody this week about the real, they say the real supercomputers are the top 100, but it's mostly the top 50 because that's where it gets really, really hard and expensive.
Yes,
Is that fair? Yeah.
They could do that, but really what I would say is that let's formulate complementary characteristic or workload and maybe start thinking about something for science.
Yeah.
What kind of science is it producing?
Okay.
And many of the scientific fields are mature enough. For example, the weather system folks,
yeah.
they can all agree on a common weather benchmark, and which sucks in maybe the ocean model, air model, and earth model, and many other things,
Right.
and then come up with that, and then see, or how many accurate forecasts can they produce with the same resolution, 20 a day or 24 a day or something like that.
Okay.
And that would put that in its correct light.
Okay.
I mean,
Okay.
let me give you an example from the same automotive industry.
Yeah.
The top 500 today with a single number is like classifying all the cars in the world by simply their horsepower. And you won't use a 4x4 in a drag race. You won't use a Formula 1 car over rough terrain.
Right.
So each one has their niche, and
Yes.
they are measured by criteria in their specific envelope or niche. And maybe we should start doing something like this
Something like this.
for our high performance computing field.
Yeah, yeah. Well, Earl Joseph and the folks at IDC had these awards things. It sounded like they're kind of going that direction.
Yes,
The
yes.
effectiveness of the machine, the
Return on investment.
yes, these
That
kinds
would be ideal. I think that would resonate with the public a lot more, because then they can see these machines doing useful work for helping to change society.
Yeah.
And it's time we moved out of all those macho flops and went into something where society would say this is a value added tool. They understand telescopes very well, they understand microscopes. You don't talk about 5 billion magnification of this, you talk about how many worlds you've discovered in outer space, or how many microbes, and they understand that and they accept it.
Yes.
I think we're mature enough to start thinking about that in this field, which is powerful than either one of these instruments.
Yes.
It can simulate everything from femto level up to as Carl Sagan would say, billions and trillions of light years.
Yeah, I mean, these numbers get so big. We were talking earlier this week about the exascale article in India, right? The guy
Yes.
basically, he added about 4 zeros to what was the project was going to be. So 132 exaflops, and I forget,
And that-
for a very good price, actually, if
Yes.
it was, I remember.
But,
right. But these
it-
numbers become just so big they're meaningless. Right?
Meaningless,
it's like the
yes.
national debt or something.
And it also shows one more thing, that the writer, quite likely a layman in this term, can easily get confused and put out wrong information.
Right.
I don't like bad data going
Yeah.
out there and creating the wrong impression.
Right, right. I mean, because we're talking about 10 to the 18th now. That's kind of, a 1 with 18 zeros. That's, that's like, what would that, is that the grains of sand in the world? I mean, or something, or
Yeah.
all the stars in the galaxy? It's all
So
big
the
numbers.
top 500 is great. We should
Yeah.
continue it.
Yeah.
But I think it's time we augmented it. I think it's time we moved it up a level and made it more understandable to the public, have correct niches or form, worlds in which these machines are delivering real value, real work
Okay.
that the public can understand.
Yeah, yeah. Well, I really appreciate you coming on the show and sharing
Thank you
your
very much.
perspective.
Yeah,
All
my
right.
pleasure.